Hey everybody, welcome to Motor Rage After Hours. See if we can span this out so you can see my ugly mug. I'm Pete Meyer, I'm the technical editor for Motor Rage Magazine. Welcome to the show. After Hours is something that we do every second and fourth Tuesday at 9 p.m. Eastern. It's a live webcast. We try to host a variety of guests to address needs and information, topics that our readers and our audience ask for. Before we get started with tonight's topic, let me just give you a few bits of information to what's coming up. May 22nd is the next May After Hours. We will have the folks from Continental to talk about TPMS, servicing and repair, and about the Ready sensor. If you haven't seen those, they're pretty neat. So we're going to find out everything about the Ready sensor and TPMS servicing with the folks from Continental on the 22nd, so mark that down. May 31st will be our second live technical webcast of 2012. That's where I go visit the folks at TST up in New York, and we do about an hour and a half long webcast there. It's live, it's in the shop, it's on the car. It's about the next best thing to hands-on training that I can get for you. You're more than welcome to attend. Of course, there's no cost. You just have to register. The link for that is motorrage.com/mechanical health. Again, that's motorrage.com/mechanical health. And I guess it kind of gives away the topic. We're going to show you some ways on how to determine an engine's mechanical condition, some traditional, some not so traditional. More and more we're seeing cars that are having intermittent misfire or drivability problems because of intermittent sealing. And that can be really hard to nail down, especially even with traditional compression and leak down tests. You can really miss it, but we're going to show you some means to find that out pretty quickly and to help you in your troubleshooting and your diagnostic time. So join us May 31st, for the webcast. And a lot of the stuff that we're doing is really hard to keep up with. I understand that. So I want you to jot this down. It's motorrage.com/vortex. Let me zoom in on that a little bit so you can see it and write it down. This is for the Certified Technician newsletter that I put out, and you can sign up for it again, just like everything else that we're doing. There's no charge for that, and you can have this delivered straight to your inbox, and you'll know when we're doing neat things here on After Hours, or the webcasts are coming up, links to the current print features. We have tech tips in there. It's all designed to make life as a tech as easy as we can help you make it. So sign up for the motorrage.com. /vortex, sign up for the newsletter. Now, the next thing on the agenda is our current topic for the night. We are going to, let me bring him up here so we can introduce him. There he is. This, folks, meet Charlie Pantano. He is the emission certification engineer with Eastern Catalytic, and he has kindly accepted the invitation to join us tonight. We're going to talk about things that can make catalytic converters go bad, and some things that you might think the catalytic converter is bad, but it's really not. It might be something else. And I'm sure Charlie's got a whole lot more of other good stuff to tell us. Charlie, hey, good night, good evening, welcome. How are you tonight?
Pete. Hi, Pete. How you doing tonight? Thanks for having us on.
Good. And again, it's a real pleasure that you're taking the time. Just want to remind everybody that's watching, just like myself and Mr. Pantano, it's way past our normal business hours, just like it is yours. And Charlie, we really appreciate you taking the time to hang out, this late in the evening to get information to the guys and gals that need it.
We're happy to be part of your show in the evening. No problem there.
Okay. Well, let me go ahead and set this up, Charlie. We're going to pull up some information that you have, and we'll get that live on the screen. Bear with me there, folks. That's one of the neat things about doing things live. And while we're setting that up for Charlie and zooming in on his presentation, and if you look to the right side of your video player and you're watching on live stream, you're going to see a chat window. Feel free to use the chat window to ask questions or offer your own comments. I'll relay them, of course, to Charlie. He'll be able to see them, but I don't want him to focus on too much. We both have a number of laptops going to make this happen, so I'll take care of relaying the questions for him. But feel free, to use that chat function to ask any questions that you want. And I'm going to go ahead and plumb it in onto Charlie's presentation so that you've got a good view. Oh, that looks marvelous. And without further ado, Mr. Pantano, it's all yours.
All right, Pete, thanks again, and hello to everyone listening on the internet tonight. We'll start with our first slide. Even though it's a small introduction, I do want to have people take a look in the background of the beautiful catalytic converters that are shown in the foreground, and that is Eastern's plant. We want to make everybody aware that we are here in the United States. We're located in Langhorne, Pennsylvania, not too far north of Philadelphia, and that is our actual facility in the back. We actually operate out of a 100,000 plus square foot of building. And the converters that you're getting and receiving for our company are made here by American people. And hopefully the guys on the internet can appreciate that, being an American company. As again, Pete just told you in the intro, my name is Charlie Pantano. I can be reached at Eastern Catalytic. And at the end of our presentation, we'll give you an idea of a web page that you can get to. And I believe also, Pete, we've included my actual email address so people can contact me directly.
Awesome.
So if you want to go a couple slides in to where we talk about the Eastern Catalytic, we're a world-class manufacturer of catalytic converters. I do most of the design along with a couple other people that help me out. And we have certifications or converters actually that we sell in over 72 countries. So we're quite big and certainly can hang in there with any of the big guys. We're dedicated to providing technicians with an advantage, and that's one of the reasons we're probably one of the only companies that you'll see shows like Pete has to offer. We try to get out as a grassroots base and visit people, and certainly we'll take advantage of these opportunities to get out on the internet. We make a wide range of products, both catalytic converters, direct fit and manifold units. We're very big in the manifold side, and that's something we'll continue to be big in. In fact, that's our niche that we claim that we have at the present moment. And we also have a line of heavy-duty converters that get used more on the industrial side and on large diesel engines. You won't, I'm sure this crowd won't have much use for large converters, but just to show you how far our range is, we've got converters operating on engines in excess of 4,000 horsepower.
Wow.
So we've got some large converter usage out there as far as horsepower ratings are concerned, and then obviously all the small engines that we see now in today's cars.
Yeah.
So basically tonight we want to talk to you guys about three main things. One of them is the troubleshooting of converter failure. So we're not going to go real in depth because we don't have the time this evening to talk about diagnostics. And I know some of Pete's other shows have covered that, and I know some future shows will. And we also have a seminar that we put on that we travel around that I can spend more time talking about the actual diagnostics part. But we're going to go into that a little bit just so everybody's on the same page of why a converter would fail. We're going to talk about some warranty check-in procedures. And Pete, you can go another slide forward for that one.
There you go.
Yep, that's it. And we're also going to talk about converter break-in procedures. Now, a lot of people don't know this exists. And I think, Pete, you and I were talking earlier about it, and I noticed you included in your intro on the webpage. There actually is a bit of a break-in to a catalytic converter. And we want to try to get the word out so people understand exactly what's happening the first time that they go to use a converter, whether it's a private installer or an installation shop. We want to try to get the word out and instruct some people on what to do. But it's something not a lot of people have heard about, and I think you'll understand it a little more as I go through what's inside a converter. Next slide, Pete.
There you go.
So, you know, how do we design a converter? What do I do on a daily basis, and why are certain materials selected? We get a lot of calls from people on our tech lines asking the material of our converter. You know, what's it made out of? Is it steel? Is it stainless steel? And there are some criteria that I have to meet when I design a converter, us and OEs also. And these are some of the conditions that you'll see on your screen. We have a huge temperature range that the converter has to work at. Basically, you know, operating here in the United States, you might see -30 to +1600 degrees F. That's a huge range. even wider than aircraft would see, for instance. And this
Wow.
converter has to last in this condition. There's long periods of high temperature. People do a lot of cruising on highways here in the States, and we also see a lot of towing with gas-powered vehicles, more here so than we do overseas. So that results in a long period of high temperature. There's also the exhaust gases themselves, which are have been getting a little bit better with reduced sulfur, but they still are very corrosive. And then there's some external forces, simply such as an engine shaking and road vibrations. In fact, Pete, I'm sure you're aware of the fact that a lot of front engine cars now have some kind of isolation between the engine and the exhaust system, and some kind of flex pipe or something that can move when the engine vibrates.
Yes.
But what's been happening recently, and I'm sure a lot of our viewers know this for a fact, is that the converters are moving closer to the engines. So instead of having a converter isolated through that flex coupling and underneath the body of the car, we're now getting a lot of converters mounted directly on the motor. So that engine, as it vibrates, directly puts that vibrational force into the torque converters themselves. At least the first one, which we call close coupled, so it's closely coupled to the engine. And that's typically the converter that sees most of the abuse if it's a vibration problem. And that may be why some of you guys see a converter come apart or crack, have more problems than you're normally seeing. And it's mostly because of the fact that all that weight is hanging off the motor.
Well, that's an interesting observation there, Charlie. Just to interject there, we have the road vibration, especially these ones that are attached, if I'm correct, right there at the exhaust manifold.
Yes.
And then you say you've got a bad motor mount that's allowing excessive movement in the engine, excessive vibration. That could be a cause of the failure to the cat, couldn't it?
Absolutely.
Gotcha.
You also have to watch out, not to push our particular converters, but it's something we try to do. Keep an eye out when you do buy an aftermarket converter that the aftermarket company is mounting the converter in the same way that the factory did. And when I say mounting, a lot of foreign cars, and even General Motors and Ford now, there'll be some kind of gusset or external mounting at the base of the converter. So you'll see a lot of extra gusseting to try to hold the converter from shaking the vehicle. So when you buy an aftermarket converter, it doesn't have anything to do with the actual emissions reduction, but you want to make sure that your aftermarket company copies the OE converter, including putting any brackets that may actually bolt or hold the engine to the car or to the converter to the vehicle.
Yeah, makes sense.
All right. And then we have the standard stuff that converters have always had to work under, including the exhaust system. That's water, salt, and road debris. So we're going to take a look at those. And next slide, Pete.
Yeah, I think I had you there. You're up.
You got it. So, what do we use and what kind of materials do we use when we do a converter? Typically, all of our converters are designed using 409 stainless steel. We do make some 304 stainless stuff for the high-performance industry. And that's typically when you have a high-performance car that might be using an entire stainless steel exhaust system. Something like maybe an aftermarket Cook's header or something like that. So, we'll see a customer like that ask us for an actual stainless steel system. In that case, we'll use 304. But all of our products that most of your guys are listening tonight will see are made out of 409 stainless. And we do that for a couple reasons. One, it's a very durable product. It doesn't rust. And it also is able to be stamped. So we need a material when we make a converter that not only is strong when we're all done, but it can form. It has some formability and can be stamped. And that's why you'll see the shape of most aftermarket converters have some stamped shape. And that material lets us do that better. And then it also has to be able to accept welding. And the 409 is a good material to weld to. And then that bottom one just repeats the formability part of it. You go on to the next slide, Pete.
There you are.
So this is a slide of what's inside a converter. And I like to show this slide. Now, I know everybody listening tonight has worked on converters or had to take them off a vehicle or seen them come apart. But not a lot of people will take one apart when it's brand new. You've got the thing brand new, you have no reason to do it. So we wanted to cut one open and just show you guys what's inside of it. We also want to make sure everybody's aware of the fact that there's really no moving parts inside the converter. There's nothing to fall apart or break. except for something we're going to talk about a little bit later, and that's that white material that you see labeled in the slide. It's called matting. So we'll have a stainless steel case. We'll have this matting that's wrapped around the converter, and then what you can see on the inside that, I'm not sure how it shows up on the internet, but it's a yellowish or goldish color material. And that's the actual substrate that you guys hear about that has the actual precious metals loaded onto the converter itself. The substrate's nothing special other than it's a ceramic product, and it is fragile. It's ceramic just like a ceramic dish would be. If it gets dropped or banged upon or actually hit with a hammer, so you installers, make sure you watch it if you're hammering on it or using a rubber hammer to see if the converter's rattling or not. Just be real careful in those areas where you see those blocks or substrate.
So you say that you could have one that wasn't rattling when you got a hold of it, but it's rattling now that you banged on it.
Absolutely. We've had people actually damage them so much that they've hit them with hammers.
Does that include like an installation? If you're using like a hammer or something to help drive it onto the pipe, that's a bad thing?
I'd rather see people a lot of times tap the converter with a hammer to see if anything is loose inside of it.
Right.
To make sure they're tapping on the inlet or outlet pipe and not on the body of the converter itself.
There you go. Gotcha.
Especially nowadays with heat shields, because you'll see not from us, but not only us, but other aftermarket manufacturers. A lot of vehicles now have heat shields built into the underbody of the vehicle. So we don't have to put a heat shield anymore on the converter body itself.
Gotcha.
So when you're hitting it, you're actually hitting only 1/10 of an inch away from that ceramic substrate.
Yeah, wow.
So really watch when you're in there. And that's actually the reason, by the way, that matting's there. It has a couple reasons. One is to hold the substrate. We need to have some kind of insulation property between that ceramic substrate, which is very fragile, and the outside world, which is just separated by that stainless steel converter body. So there has to be something between the two to insulate it when it gets cold or splashed with water. And that's what that that matting does.
Oh.
It's a couple things, and we'll get into a little bit later what the matting looks like and what it does, because I think that's really the most important part to me as an engineer of the converter. Next slide.
There you go.
Right, so you guys, everybody on the net, I'm assuming, has some diagnostic expertise, and they've worked on converters and repaired them. And we just want to get the word out that we see a lot of converters come back to our facility that are actually fine. There's nothing wrong with them. Now, when I say that, I don't just mean that we take a look at it and blow it off as a return that somebody shouldn't send us. We actively test converters, even used ones. So part of our QC process and part of my testing process is that when we get a return converter or we see a series of converters come back, I test them. So these are used converters with possibly 50 to 100,000 miles on them of road service that have been returned for some reason. And more times than not, we test the converter and it still functions. It still works correctly. And we want to get the word out to people to do as good of a job as they can on the diagnostic side. And that's where we get into some of this diagnostic stuff. The engine components that are key to the converter efficiency and failure. And we want customers or installers or end users to understand that there's a lot of things that can happen upstream to cause converter malfunctions and that big PO420 code that everybody sees.
Right.
And we just want to have people find those problems and prevent reoccurring warranty issues. That's really the goal of it.
Sure.
Not to beat up installers and tell them they don't know what they're doing. Next slide. And in fact, if you'll see from this next slide, there are quite a few things that we've identified that can cause failures on catalytic converters. I don't think there's any argument that most of the stuff on this list, especially O2 sensors, I'll go through each one a little bit, but O2 sensors not only being sluggish or not working correctly, but maybe skewed in some way so that their center point, the center oscillation voltage, which should typically be around 0.45 volts, maybe that voltage is skewed a little bit high or low. It looks like a perfectly good running signal, but it's actually skewed to the rich side or the lean side, causing problems. Fuel injectors, we see this problem all the time with leaky fuel injectors. Fuel injectors that don't shut off, or even though you're giving them the right duty cycle, are just on the rich side and being leaked through the system all the time. Spark plugs, mostly with incorrect plugs, people using the wrong heat range. You know, a non-extended tip versus a projected tip, those kind of problems. We see a lot of problems with EGR valves, believe it or not. The EGR valve is primarily responsible for reducing combustion temperatures. That's the whole reason there's an EGR system on the car. It reduces NOx emissions when we measure them through the converter. And without a functioning EGR valve, NOx goes up and so does your exhaust temperatures. And exhaust temperatures are one of the reasons that we see that matting fail. And then there's your typical vacuum hoses and you know, the MAF sensor that's on the vehicle. We don't see too many of those causing converter failures, but they can skew the richer lean condition of the motor, and that's a concern at the catalytic converter side of it.
Sure, because either one of those directions, and all these things kind of have that in common. Either plus or minus from where they should be is going to result in high exhaust temperatures, and that's not what the cat wants to see, right? So.
Exactly. If you look back to that, you know, you don't have to go back, but if everybody remembers that previous slide where we talked about temperatures, you know, the catalytic converter is really only designed to work up to about 1600 degrees F. A car, you know, typically today's motors will run from 12 to 1400, so you've only got a couple 100-degree window of high temperature before you get into trouble. Trouble meaning you would see the temperature that the matting could operate in, and then we have matting problems. We'll talk about that a little bit later too, Pete. What happens when that matting fails?
That's good.
Next slide.
There you go.
All right, so we're going to talk about some of the conditions that do cause failures, and this leads right into what we were just talking about: thermal failures, excessive temperatures that cause a high-rich fuel mixture failure. This can be leaky fuel injectors. That can be vacuum leaks. A lot of times it's an exhaust leak. You know, people don't realize the exhaust manifold has a crack in it. So we've been getting a lot of our installers using smoke machines. I'm not sure, Pete, maybe we'll hear later on from some of the guys how many actually have used a smoke machine to check the exhaust side.
Oh, I have. Yeah,
you know,
that's a great tool.
We're getting the word out there, and I'm getting a lot of guys in their shops now that have smoke machines. You know, mostly to check evap systems, but we want to make sure they're aware of the fact you can plug them in other areas of the engine and do some other testing with the same tool.
But just as a side note, real quick here, Charlie, I mean, we have got some really good resources at motorage.com. I can think of 2 or 3 right off the top of my head, print features that went through 420 diagnostics, went through exhaust system inspection, you know, using sound, using smoke, and I encourage anyone who's watching, you know, log on there and use the search function, you know, dig into back to those past issues. That's why we put them there, and use that information to help you.
Exactly, Pete. I think when it comes down to modern diagnostics today, that's what it takes. It takes somebody's skills in all the areas, you know, and knowing what all the equipment is available, and to be able to mix that all together and use it for different techniques. It's just like you're describing.
Yep, absolutely.
And the results of these high temperatures are what we see a lot of. That's this matting erosion or burnup. What happens is the matting gets so hot, it starts operating out of its design range. You know, temperatures above 1600, 1700 degrees F. It actually burns the matting, just like you were heating it with a torch. And the matting will erode. You have the exhaust gas going there, creating some pressure. You've got some heat that's destroying the matting, and eventually that matting will erode and no longer be able to hold that substrate in the converter, and that's when people will start hearing the converters rattle.
Oh.
I'm sure everybody's heard that rattling noise, or you know, almost sounds like a loose heat shield. But when you hit on the converter ends a little bit, you actually hear it rattle on the inside.
Yeah.
That's our #1 cause, an over temperature condition causing that. And we want to let people know that that's out there. We do see some burned up and melted converter coatings. We'll show some pictures of those at the end of the presentation. But if anybody's ever looked inside a converter and actually seen it melted, that is extremely high temperatures that the converter's seen. You know, in excess of 2,000 degrees F.
Sure.
And we want people to know that, you know, nothing happened, nothing in the converter caused that. Something in the motor is causing that condition. And then we'd see some clogged substrate. Clogged substrate is starting to show up. primarily been visible in trouble vehicles. I don't know, Pete, if you've the 3.8 liter General Motors have had a problem with antifreeze leaking through the intake manifolds, problems like that.
Yep.
Head gasket problems that cause antifreeze leaks. Whenever you have a problem like that, and antifreeze gets into the converter or comes through it. Basically, if you've seen antifreeze come through the converter and generate that white smoke that you see at the end of the tailpipe when you have a bad head gasket,
Yeah.
you've pretty much hurt the converter. Chances are pretty good that it's not going to come back.
Oh, very interesting.
Yeah, people try. You know what'll happen? People they'll do the head gasket fix. They'll start the car up and run it for a while till they stop seeing the white smoke. Figure they fix the head gasket and then give the car back to the owner. And
Sure.
really, a month or two later, we'll generally see those vehicles come back with a bad catalytic converter. Now, it might come back to a different shop, and you might not see it as you're, let's
Sure.
say you do head gaskets, you don't do converters, so you might not see them again. But I can tell you, we see it on our end and on our tech line, we see that problem a lot.
Wow, that's very interesting. I personally never thought about that. I see another common issue. I won't name brands here, but I know that there's a few models that are known to get some rings stuck and burn oil, and the exhaust is so good. I guess what's happening is that it's clogging up the substrate because they won't smoke.
Exactly.
Exactly. Very.
We've actually seen that problem. I don't mind naming a brand because they're causing me trouble. but General Motors, a lot of GM like Sierra pickup trucks, the 5.3 engines, the 6.0s, they have a lot of oil problems, both with stuck rings, and they also have not an EGR, but a PCV valve problem right now. I believe there's a TSB out on it. Basically, the engines burn a lot of oil, and a converter cannot take that excessive burn oil and pass it through. Mm-hmm. It starts clogging the holes up and causes some problems. General Motors is actually down to making a statement that a quart of oil every 500 miles is not bad for the engine. That's what they're at right now with their statements.
Wow.
And we can't take that through our converters. Nobody can.
Sure.
All right, next slide.
There you go.
Yep. We also want to talk about some other contaminations that you don't think about. We see this in our testing at some of our test labs, and we just want to make sure people are aware of it. And one of them is silicone products. The high temperature silicone that you guys are normally used to seeing. That red high temperature silicone.
Yes.
You cannot use that on any part of the exhaust system. Not on the header gasket or the manifold gasket, and certainly not on O2 sensors. We'll show a little bit later a couple pictures of what happens when you do that. They're not real graphic, but I can tell you the results are graphic. What happens is that silicone burns off, it outgasses when it sees temperatures that the converter operates at, and it causes a film. Just like, I don't know if there's any body shop guys out here listening to us, but from experience that if you take any kind of silicone and spray it in a body shop area, even a little bit of it, the paint doesn't like to adhere to the cars anymore. It's the same thing that happens in the exhaust. That silicone outgasses and it coats the O2 sensor and also some of the surface of the catalytic converter, reducing its capability to clean exhaust gas. Wow. So we don't want to see anybody use silicone gas or gasket material. In fact, if we see it on a return converter, we won't warranty it. So that's something you need to watch out on your end.
Yeah,
it's just something that we know is a problem. I believe we're putting a label on all of our packaging now, warning people about it. And I just want to get the word out to not use it in the exhaust stream. Perfectly acceptable, in intake manifolds and parts like that.
Well, but I'm actually surprised to hear that you're seeing that on exhaust components. That's
some guys will still use it like to seal a gasket. I actually don't mind sealing a gasket downstream from the converter. A lot of muffler shops will use it to seal like a slip pipe fitting or something. Just don't get it anywhere in front of the converter if you can help it.
Sure.
Okay, next slide. Actually, there's some pictures on our next slide people can see.
Yeah, I'm going to point it out here, but I can see it here really well. Here's the manifold, and there's the red silicone. I'm going like, wow. I mean, and here on the O2 sensor, that's amazing.
And if you look, they're also using it on the O2 sensor, like you said. And we all know that the O2 sensor seals with that gasket that's around the bottom of it. You know, there's
Sure.
a small compression gasket. The threads are straight threads. They're not a pipe thread, so there's no sealing property in the threads.
Right.
And you really shouldn't have silicone on this part at all.
No, of course not.
You know, and we've also seen people use Teflon too. Same kind of end results.
Teflon, really?
Yeah, I get them back all the time. Because a lot of times the shops, since they're doing an O2 sensor sometimes at the same time, we'll get the repaired converter back with the old O2 sensor still stuck in it. So I get a chance, believe it or not, even though we're selling catalytic converters, I get an opportunity to see a lot of O2 sensors.
Yeah, I bet
just
you do.
they can return it.
Wow.
Exactly.
Wow.
All right, so that's my beef on silicone products. Hopefully people find something better. I don't know of any product that's, you know, let's call it O2 sensor safe, other than when used in lower temperature areas, like on an intake manifold gasket, those kind of areas.
Yeah, I would say that on the O2 sensors, I mean, most of the better brands have a small, and I stress the word small dab of anti-seize, you know, on the threads. And just as a side note for you guys and gals that are watching, even an excessive amount of that's no good. So, you know, just if you're going to use anything, just a little tiny dab of O2 anti-seize on the threads, you know, that could be of a benefit, but certainly, goodness, not red silicone.
Yeah, in fact, I can tell you a story about anti-seize. On our drag race cars, we like to use anti-seize a lot because most of us use, you know, a fairly high dollar aluminum head. So
Sure.
we'll always use anti-seize on the spark plugs. And I could tell you from tearing engines apart, I see a path, you know, depending on how much anti-seize you use, I can definitely see a path of it leading, you know, out the exhaust valve into the combustion chamber and back out the exhaust port. So it can travel quite a distance, even in a combustion chamber.
Good point. Good point.
Yeah. All right, next slide.
There you go.
So we talked a little bit earlier about fouling. You know, anti-seize, or not anti-seize, but antifreeze leaking from manifolds and oil from head gaskets. Older engines that burn oil, and like you just talked already, Pete, about stuck rings and form valve guides. And anything that's eating a lot of oil, you know, certainly in excess of a quart every 1,000 miles or so, to me would be excess.
Yeah.
You're eventually going to hurt the converter. Not right away, but you're going to reduce the mileage that you get out of it.
Yeah, and you guys have to warranty these things for quite a while, don't you?
Yeah, absolutely. We the EPA requires us to warranty it for 25,000 miles. Eastern actually warranties it for 50,000. We double that mileage, even though we don't have to, because we're a little more confident about our product.
Sure, sounds good.
But we do have to cover for the entire 50,000 miles, or 5 years.
Yeah, and then of course, I mean, the factory emissions warranty is what, 880 on the.
Yeah, some of them are going long. Not this presentation, but the one I do with travel. We got to make a point of showing how some of the factories have to extend that warranty because they have problems with the converters themselves.
Right.
So there are some warranties out there going out to 220,000 miles.
Yeah, and some of this is probably reasons why they're having those problems.
Yeah, they
Okay.
try to stay 80,000 unless they have to.
Sure.
So some of the results of this oil can plug it. That's typically the result that we see. A person will send a converter back, and the small holes that you see in the end of the substrate will be plugged, and that's from the oil burning. It reduces the efficiency the whole time you're running like that, and it just doesn't last very well after it gets coated. Next slide.
There you go. That's what we were talking about.
Yeah, absolutely. Good lead-in. So the EPA requires warranty against defects and workmanship. They actually only require 25,000 miles. Eastern goes the whole 50,000. And then we want to make sure people check the CAT before they send it in. Now, typically converters are sent to distributors. Eastern Catalytic is a company that sells mostly through a distributor network system. So most of our people listening, I would believe, if they're buying Eastern product, are buying it from a local distributor of some kind. So, you know, we want to reduce the warranty claims as much as we can, and we're trying to educate both installers and distributors on, you know, what we will and won't take back.
Sure.
So we want to make sure people understand the cause that the converter went, especially if you have a factory part in the converters, is already going underneath that 80,000 miles. You need to look at why the factory one failed before you go and bolt an aftermarket one back on.
Yeah, and I think I'm going to stress that again, Charlie, because it's been my personal experience that a lot of times the 420 code, for example, really isn't in the converter, and if it did fail, as you pointed out, there's no moving parts in there. Something made that thing die. You can replace the symptom, but if you're going to do a professional job, you need to make sure that you not only replace the damaged component, but you repair the reason that component got damaged in the first place.
Exactly. I mean, we're always trying to say that on our end because we make catalytic converters, but in the last 4 or 5 years, it's really become commonplace where people have been educated about, other things that can cause this PO420 code, just like you described, upstream problems that the engine might have to start out with.
Yep.
All right, next slide. We'll talk about some things, that are just obvious problems we won't warranty.
Yeah.
We get these back. In fact, that's where these pictures come. Everybody takes a shot at warrantying something, and I don't blame them. I would do the same thing. But we want to make people aware that there are some problems that just flat aren't going to be a warranty issue, and that's road impact. You saw how fragile that distance is between the outside can and the mat. It's only about 1/10 of an inch.
Right.
And when you get a dent like this, there's no way the converter can last through it.
Sure.
We get that back, that would be a warranty issue. So next slide, Pete.
There you go.
So there's a small warranty checklist. We also have some wall products that people can pick up at their distributors. It'll show things that look at a converter. It also shows some pictures of converters and how they relate to engine problems. So if any of our installers out there have a local distributor they're dealing with, they can always get those, it's like a wall placard that they can hang up.
Awesome.
So, they'll look at road impact. Even if you have a road impact, you should check the converter. A lot of converters have heat shields on them, and it may just be that the heat shield got damaged. The inside of the converter is not hurt. And you can do that by checking there's rattling inside. We talked about, hitting converter body. I say hit it, tap it with a sand hat or rubber hat on the inlet or outlet. Don't try to tap the body.
Right.
And then sometimes you can look inside. If guys have, bore scopes that people are using to look at an engine,
Yes.
unscrew your O2 sensor and look inside with the bore scope. There's another tool you have probably in your shop already, and you can get a good look at the front surface of the converter. You should be able to see whether it moves. You can certainly see it's clogged up. All right, next. Another problem you see a lot of is damage. It's something we look at when a converter comes back for a warranty issue, and we basically look at the material itself. We try to get an idea for how hot it's been. The next slide.
There you go.
So we'll examine the steel shell itself. We'll look at the unit. The aluminized tubing that we use will actually turn a real dark gray. The reason these color changes is the temperature's got so high that the material will actually change composition.
Yes.
The aluminized tubing we use literally has aluminum into the tubing because it doesn't rust. People sometimes look at the converter so hot that it melts the aluminum. And we also want to melt it, turns that gray color.
Mm-hmm.
The shells, the 409 steel, they'll stay like a golden brown color until you get too hot. And at some point, some of the iron will actually come fit and you'll see rust. So when you see a stainless steel converted body really turn rust, typically the converter's got hot.
Yeah.
And then we check plug bricks in the front converter. When we get a converter in for warranty, we'll typically cut it open and look at the surface. If people think about it, that front surface of those small holes is really a good telltale sign of how the engine's been running.
Sure.
You can tell quite a bit from it, right? We can see a lot. We can see engine debris on it, the antifreeze. We can plug hole from oil consumption. So it's kind of like our little how the engine's running. And you guys listening on can see the same view by using a board scope, or if you have system can actually see it on the front converter. All right, next slide.
There you go.
Chemical damage. When we say chemical, we in anything that's going to the engine that should be. And by the way, it's also related a little bit to people that clean engines with products. You know, I don't really know the trade names because we use it much, but any type of fuel injection cleaner, I think we use that. You might know the name, foam or something like that. I think it's called.
Yeah, that's one product. Yes.
You know, just basically engine cleaning product. You have to be careful if you are actually cleaning off carbon deposits, cleaning up large debris, say off a pickup. That debris has to go through the converter somehow. It's going to get caught on the screen, and we want people aware of that. I like to see engine cleaning, but more often than not. In other words, not one big cleaning at 150,000 miles if you have a problem.
That's a good point. So that's a good reason to make that, you know, just part of routine maintenance. But
Absolutely.
Yeah.
Definitely not knocking the product. I use it myself. Would like to see it used more often. And it's a tough sell, but you know, I'd like to see it like every 40,000 miles or so. Try to upsell it to people and not try to use it when tough car and, you know, with 100,000 miles and you're going to try in the engine.
Yeah. Now let me ask you real quick, Charlie. I mean, let's just say, because as a tech, I had that a lot. You know, you get a car in that has not been maintained, and we all know that the consumers aren't spending any more money than they have to. And it does need an injection cleaning. It does need to be decarboned. I guess at this point, would it be safe to say that it'll be loud as hell, but it might be best to drop that converter, you know, when you blow it out, when you clean it out. Otherwise, everything that you're cleaning out of the engine, you're dumping right. It's kind of like what we talked about 2 weeks ago with Paul DiGiuseppe on heat exchangers. You know, these ports are so small that you cannot expect that debris that you're forcing out of the engine to make its way, you know, through those ports, the length of that converter, and not cause some problems.
Yeah, I mean, people have the same problem with heater cores, right?
Yes.
It almost pays to figure out which way the flow has been going. You know, figure out the direction of the flow and try to clean it out backwards.
Yes.
We can't do that with converters, obviously, because we're flowing it back to the engine. But yeah, if you have an underbody converter that's simply a flange, you know, a 2 or 3 volt flange, then you could lean down for a little bit. It would be my choice of how to do it. The problem is most cars today, though, are going to have a close coupled or manifold converter that's bolted right to the motor, and you really can't get it off.
That's true.
All right, so that's something, you know, it's something to be aware of, and you know, certainly if you cleaned an engine and had a problem after that, now you know where to look. You know, the problem might have moved down port somewhere.
Mm-hmm.
All right, next slide.
There you go.
That's really just a repeat of what we talked about before. That we see a lot of contamination from antifreeze. Little bit of fuel additives, meaning we've had some customers that religiously use fuel additive. I mean, like, you know, every couple gasoline fills.
Right.
It's good to use. Everything's good to use once in a while, but not excessively.
Well, look, I got to ask another question here for clarification. If I'm dealing, and this, I know we're not going to have time to really get real deep into 420 diagnostics, but if I'm dealing with that type of code, and I pull out my bore scope and I check the inlet side of the converter, and I see melting, clogs, cracking, anything at all like that, then like or not, the converter's health is in question, but it's certainly not the cause. If I look inside the converter and it's all clean, tight, looks good, then it may be a possibility that the material itself it has a problem. You know.
Absolutely.
Okay.
Absolutely. I mean, converters definitely go bad. We're never, you know, I would not be the person to sit here and tell you they could never go bad.
Oh, sure.
But we want to look at a lot of things to get to that point. Definitely.
Absolutely. Okay.
All right, next slide.
There you go.
This is a substrate damage problem. We want people to be aware that we do see this damage. Sometimes it's literally a thing where the block had cracked. The substrate formed a crack, and then after continuous use in the vehicle, it finally finished cracking all the way through and breaks up. We'll see this on high temperature conditions, and then also some road damage where people hit the side of it. But it's something to look for. You want to make sure all those holes that are in the converter are open.
Mm-hmm.
Especially in new vehicles, the aftermarket industry typically uses a converter that has 400 cells per inch. So if you took a square inch of our converter, or most of the aftermarket product, there'd be 400 small holes that you can see. They're about 6,500 thousandths wide. Not a very big hole.
Mm-hmm.
On the OE side, though, the holes are getting smaller and smaller, up to about 1,200 holes right now.
Wow.
So there's OE cars, mostly like Honda Civics and some foreign cars, where they had to get a lot of surface area of converter very close to the motor. You're talking about holes that are only 2,500 thousandths wide.
Wow.
So when you guys are cleaning out carbon and whatever, any kind of debris through the engine, it ultimately has to get through a hole that's only 2,500 thousandths wide.
Again, I got to point out the similarities between that and the modern heat exchangers that we had the pictures of that were no bigger than a toothpick. So
yeah,
absolutely. Good.
All right. Next slide.
There you go.
All right, these are just some warranty checklists that we ask people to look at. Check to make sure the converters, check the converter for the manufacturer's stamp code. Some converters have multi-pieces, so check the listings, make sure that all components have been returned. We get a lot of returns that are, missing parts, or maybe the guy used the gasket and didn't put the gasket back in. We're real lenient about the gasket part. We understand that the installer may have had a problem, but we want to make sure that we get all the parts. And certainly, we want to make sure if there's two converters in the system, we get both of them back for warranty.
Sure.
There's just a little thing people should be aware of. Next slide. And we're just for our internet listeners, we're getting to the end here, Pete. We only have a few more left, and then hopefully we have some people that might want to have some questions.
Sure.
And this is something I want to spend just a couple minutes on. This is the next slide. It's labeled converter break-in period.
There we go.
All right, this is something that Pete's put in his promo to our conversation tonight. That's something we go around and really center on in our seminars to make people understand it. There actually is a bit of a break-in period with the catalytic converter. I know it sounds crazy to some of the guys because we just got done saying there's no moving parts, but there is a part in the converter, and that's that matting that we discussed earlier, that white product that's called matting.
Mm-hmm.
There is a break-in period for it, and we want to make sure people understand it. We never made a big deal out of it before because a lot of converters were being installed by shops and installers. Nowadays, the converters are literally installed by do-it-yourselfers, especially with Eastern's direct fit line of converters where they just bolt on.
Sure.
A lot of people are trying to take this into their own driveways and do it, which is fine. That's why we make the converters. But we want to make sure they have some of the same expertise as some of the installers do so they get it right. Mm-hmm. But there is a break-in period. The matting itself, that matting that we talked about that's wrapped around the substrate, when it's installed and leaves the factory, it's in its virgin state. That matting is actually made up of a couple of materials. One of them is a product called vermiculite. Vermiculite is a rock or a stone, been around for years. It's actually been used in the heating and air conditioning industry. People will see it wrapped around their heat ducts sometimes in older houses. It's a replacement for asbestos. But it's a stone. It's a mineral that actually expands when it gets hot. It's kind of a powdery material, so it's not very easy to handle. And what our coating company does, not coating company, but company that makes our matting for us, they actually bind it with a polymer so it doesn't fall apart. So when you get your first converter, when you get your converter from us, it has this matting in it that's in its virgin state. It's a white vermiculite product that has some binders, some rubberized material in it to hold it together. Mm-hmm. You first start that converter. When the converter first sees heat for the first startup, the first thing that happens is that binder actually burns away. So the binder itself burns away from the heat of the exhaust, and the actual matting gets thinner for a period of time. So think about that. We're selling the converter, everything's tight, the substrate can't move, but when you first start the engine, that matting, the binder that's inside of it burns away, and that grip force, the amount of force that holds the substrate, actually reduces for a small period of time. It's really short, it's only a couple minutes. And after that period of time, as the converter does start getting heat in it, up to about 500 or 600 degrees, that vermiculite that we talk about expands. Okay, so that rock, that mineral material actually expands and starts gripping the substrate like us engineers and the manufacturer of the actual matting designed it to do. So there is a break-in period. There's about a 5 or 10 minute window when that matting actually doesn't hold as well as when it was shipped from our factory. And we want to make sure people understand that. All that you have to do, and there's a small break-in procedure. I'm not sure if we listed it in here or not.
I think so.
But it's very simple. We're just asking anybody that installs a converter, any of the installation guys or the shops that are listening right now, make sure you're the first guy or the first shop that breaks that converter in. Start the converter, let the car idle below it. Do not take the vehicle on road at this time. Just bring it up, let it get hot for the first time, and once that's gotten hot and expanded, that's it. The matting will stay in that condition for the life of the converter.
Yeah, I kind of went ahead a little bit on your slides.
That's excellent. I saw it come up on the screen.
I got that picture there showing the unexpanded and expanded version. And and there's the warm-up procedures, guys. Just to recap, Charlie, why don't you run through those one more time?
Sure, and actually, everybody was looking at that picture. What you saw is the thickness of the matting when we install it out of our factory. That was what you saw on the right-hand side of it, called unexpanded. And then what you saw in the free expanded picture is how big that matting can actually get. Now, it doesn't get that big because it's held between the converter body and the substrate. It really, if you looked at it, it never really gets any bigger. But there is a reduction of grip force the first time you start it.
Right.
And it remains there until the converter gets to about 600 or 700 degrees. So we'll go to that last page which everybody's reading. Start the vehicle. Do not rev. A lot of guys like to start a car up, rev it to see if they've just made the correct fixes. If it's a converter, don't do that. Let the car idle. Let it warm up as slowly as you can. It's okay to back the vehicle out of the bay and do it outside. I'm not asking people to do this while it's still on the lift. But, bring the RPMs up a little bit if you can, certainly a minute or two. And as soon as the converter's gotten up the temperature, all those events have occurred already for you. The mattings burn off, or the polymers, coatings that are inside of it, the binders have burned off, and that matting's had a chance to expand or pop, as we call it, popping the matting. And then go ahead and do your test ride if you want to, or turn it back over to your customer, and they should be fine. This is responsible a lot for early failures. If any of you installers out there have seen something come loose, that rattling noise, if you've seen that in the first, couple hundred miles of a vehicle use, and you're just curious of what happened, this could be an area that you need to look at. Was it broken in correctly, and did somebody spend a couple minutes warming it up for the first time?
Awesome.
All right.
Yep.
And that's pretty much our presentation, Pete. I hopefully that was enough to show some people what we're talking about and instruct them on what catalytic converters are about.
Yeah, I'm going to leave this information screen up for just a couple of minutes for the folks who are watching. If you want to get Charlie's information, you can reach him at Charlie Pantano at easterncatalytic.com, or go to easterncatalytic.com for a variety of informational sources. Also find you guys on YouTube, right?
Yes, we do have some YouTube videos. You'll also find those same videos on our website. You can click on them and move over to YouTube, or use the YouTube sites to pass it around and show other people.
Awesome. And again, I know that after our discussion earlier, you're going to be able to share a lot of that information with them through the community site, which would be really cool.
Absolutely.
And haven't seen any questions pop up here yet. If you do have any, now's a good time to ask the questions. But I think, Charlie, you did a heck of a job. I know I certainly don't have any more.
I appreciate that.
Very good presentation, very informative, and as always, I learned something. I hope you guys did that I never knew before. I'll certainly be a little more cautious about doing fuel injection services and cleaning. knowing of what might go downstream through those 2,500 openings, or not going through them rather. So some very good points there. And again, Charlie, I want to thank you so much for taking the time to hang out with us on After Hours. And
Pete, thanks very much. We appreciate you having us.
And with that, again, don't forget, guys, May 22nd, we will be hosting Continental, and topic is TPMS and the Continental VDO Ready Sensor. Should be a very informative after hours. May 31st, webcast. You can sign up for that at motorage.com/mechanical health. Or easier, just go to motorage.com/text, sign up for the newsletter, and you'll know what's coming up and when it'll be delivered straight to your inbox. So until next time, this is Pete Meyer, Charlie, have a great evening.